Welcome back. Let's practice solving basic general inequalities. All right, so here's our first example. We want to solve the inequality and graph the solution set on a number line. And we're given 5x minus 6 is less than 3x minus 2. Okay, and so remember, our goal in solving inequalities is to isolate the variable, or get the variable by itself, such that it is being compared to a constant value. And in this case, our variable is x, so that's what we want to solve for here, which means that the first thing that we need to do is eliminate one of these two variable terms, right? In this inequality, we have a 5x and a 3x, but in order to solve for x, we just want one instance of x, not two. So what we should do here is make use of the addition properties of inequalities and add the opposite of one of these two terms to both sides of the inequality. In this case, I will choose to add the opposite of 3x to both sides, which would be negative 3x, or if you want, you could think of it as subtracting 3x from both sides. But by doing that, this 3x and this negative 3x will cancel out to be 0. But then over here, we want to combine these two terms, 5x and negative 3x. They have the same variable part, so they are like terms. Just add the coefficients, 5 and negative 3, combine to be positive 2. All right, so we get 2x minus 6 is less than negative 2. All right, and so now we only have one instance of that variable of x, which means that we are one step closer to being able to isolate and solve for that variable. Okay, so just remember, you can add or subtract any term you'd like from both sides of an inequality, and the solution set to that inequality will not change. So subtracting 3x from both sides does not change the solution to this inequality, it just helps us get the inequality into a form where we will be able to solve for the variable. All right, but then continuing on here, in order to solve for x, we do have to get this variable term by itself on one side of the inequality. So we need to get rid of this constant term of negative 6, which we could do by adding the opposite of that to both sides of the inequality. And so that means we want to add 6 to both sides, right? Negative 6 and positive 6 added together are 0. So you're just left with 2x is less than negative 2 plus 6, which is positive 4. Okay, and then our last step here to solve for x is to get rid of this coefficient of 2, which we can do by dividing both sides of the inequality by 2. The multiplication properties of inequalities tells us that we can multiply or divide both sides of an inequality by the same value, and the solution set will remain unchanged, at least in the case of a positive value. Okay, in a later example, you will see that when we multiply or divide by a negative number, we do also have to flip the inequality sign, but that is not something that we have to do here, since this coefficient is positive. All right, so we'll divide both sides by 2, and our final result will be that x is less than positive 2, right? 2 divided by 2 is just 1. Those 2's cancel out, so you just have 1 times x, giving you x, and then x is less than 4 divided by 2, which is 2. And so x less than 2 is the solution set for this inequality. And so let's graph it. Let's plot it on a number line. If this is x equals 0, then I'll let this be x equals 1 and x equals 2, right? 2 is the value that x is being compared to. And specifically, we're looking at values of x less than 2. So 2 is not included in the solution set because it's not less than or equal to 2. It's just less than. So I will draw an open circle at 2 and then draw an arrow in the direction of values less than 2, which would be numbers to the left of 2 on the number line. Okay, but that would be the graph of x less than 2 on a number line, which means that we have now finished this example. Let's take a look at another. For our next example, we want to solve this inequality and graph the solution set on a number line. We are given 8y minus 9 is greater than 3y minus 9. Okay, so in this inequality, the variable that we want to solve for is y, but it doesn't matter that the variable is different. Our solving process remains the same. The first thing we want to do is get rid of one of these two variable terms so that we only have one variable term in the inequality, making it easier for us to isolate and solve that variable of y. All right, and so those two terms are 8y and 3y. I'm going to choose to get rid of 3y. What I'll do is add the opposite of that to both sides of the inequality. So you would add negative 3y, or think of it as subtracting 3y from both sides of the inequality, because then 3y and negative 3y combine to be 0, they cancel out, and then 8y minus 3y will be 5y, right? These two terms are like terms, they have the same variable part of y, so combine their coefficients, and 8 minus 3 is 5. So we get 5y minus 9 is greater than negative 9, so we are now one step closer to solving for y here. We now just have one variable term, but we do want to get it by itself on this side of the inequality. And so let's get rid of this constant term of negative 9 by adding the opposite of it to both sides of the inequality. So I'll add 9 to both sides, and negative 9 plus 9 is equal to 0, so those cancel out. And the same thing will actually happen on this side of the inequality as well. Negative 9 plus 9 is 0. So what we're left with is 5y is greater than 0, which means our last step to solve for y is to get rid of this coefficient of 5, which we can do by dividing both sides of the inequality by 5. So if we do that here, if we divide both sides by 5, these 5s will cancel out. 5 divided by 5 is 1. 1 times y is just y. So we will have y greater than 0 divided by 5, but 0 divided by a number like 5 is just going to be 0. So what we end up with here is y is greater than 0. That is the solution to this inequality. And so that'll be pretty simple to graph on a number line. I'll just label the center as 0. That represents y equals 0. And the values of y included in the solution set are any values greater than 0. So 0 is not included. This is not a greater than or equal to sign. So I am going to draw an open circle at 0 on the number line, but then I'm going to point an arrow in the direction of values greater than 0, which are all the positive values to the right of 0 on the number line. Okay, and so that will be the graph of this solution set, which means we are now done. We have solved this inequality and graphed its solution set. Next up, we want to solve the inequality and graph the solution set on a number line, and we're given negative x is greater than or equal to 0.2 times the quantity 40 minus x. Alright, so in this inequality, the variable we want to solve for is x, but also notice that in this inequality, we have some parentheses. The first thing that you want to do in any inequality that involves parentheses is get rid of those parentheses, okay? It's going to make it much easier for you to solve for the variable if there are no parentheses in that inequality, okay? And so to do that, we most likely want to distribute 0.2 through this quantity. We want to multiply 0.2 by 40 and multiply it by negative x. But before we do that, working with decimals can sometimes be tricky without a calculator, and so if you are using a calculator, feel free to do so. But since I want to try to do this work by hand, I am going to rewrite this decimal as a fraction. Because what this represents, 0.2, is 2/10, right? The first place after the decimal is the tenths place. So if you have 0.2, that represents 2/10, or essentially 2 divided by 10. Okay, so I'm going to rewrite this inequality to be negative x greater than or equal to 2 divided by 10, or 2/10 times 40 minus x, okay? And now I'll distribute 2/10 through this quantity. It's just going to be easier to work with than the decimal. So I'll multiply it by 40, and then multiply it by negative x, and we'll have negative x greater than or equal to 2/10 times 40, which I'll write like this. We'll have 2 times 40 divided by 10, right? You just want to multiply 40 into the numerator of the fraction, and we'll simplify that then. But let's multiply 2/10 by negative x, and that will give you negative 2/10 x. All right, you just multiply 2/10 by that coefficient of negative 1, which will give you negative 2/10, and then of course you keep the x. Now, let's simplify this fraction. 2 times 40 is 80, so I'm going to erase that here, and we have 80 divided by 10, which is 8. So we have negative x greater than or equal to 8 minus 2/10 times x. Okay, and so now we've gotten rid of the parentheses in the inequality, but now what do we do next? Well, we have two terms that involve that variable of x. We should try to get the inequality in a form such that there is only one variable term. So let's get rid of one of them from one side of the inequality. And I'm going to choose to get rid of this negative 2/10 times x. What I'll do is add the opposite of that to both sides of the inequality. So I'm going to add 2/10 x to both sides. And so negative 2 tenths x and positive 2 tenths x will combine to be 0. But then what about negative x plus 2 tenths x? Well, they are like terms. They have the same variable part of x, so we just have to combine their coefficients. Negative 1, that would be the coefficient of negative x, and positive 2 tenths. So doing that on the side here, if we have negative 1 plus 2 tenths, what would that be equal to? Well, you would want to rewrite negative 1 to be in terms of tenths, so that these two terms have common denominators. And so what you could do is multiply negative 1 by a form of 1 of 10 divided by 10, because that would just be 1. So you're just multiplying 1 by negative 1, which doesn't change its value. But by doing this, you'll rewrite negative 1 as a fraction in terms of tenths, which will be negative 10 tenths, which can now be easily added to 2 tenths. Negative 10 plus 2 is a negative 8, so this is equal to negative 8 tenths. So that is what the new coefficient of x will be on this side of the inequality. So let's write that out. Continuing our work over here, we now have negative 8 tenths times x is greater than or equal to 8, right? We still have that 8 on this side of the inequality, so do not forget about it. But that would be it, because negative 2 tenths x and positive 2 tenths x canceled out to be 0. All right, and so now our inequality only has one variable term, which is good. We just now need to isolate that variable. And to do that, our last step is to eliminate the coefficient of that variable, which is negative 8 tenths. So what we need to do is divide both sides of the inequality by that coefficient. Or since it's a fraction, an easier way to think about it is we want to multiply both sides of the inequality by the reciprocal of that fraction. That would be the same thing as dividing by that fraction. Okay, and so the reciprocal of a fraction is just that fraction, but where you flip the numerator and denominator. So what I'm going to do is multiply both sides of the inequality by negative 10 eighths. Okay, I just flipped the numerator and denominator, giving me the reciprocal, and multiplying both sides of the inequality by that reciprocal of this fraction will eliminate that coefficient, because negative 10 times negative 8 is positive 80, and you're dividing by 8 times 10, which is also positive 80. So 80 divided by 80 is 1, just giving you a coefficient of 1 for x, which is exactly what we want. So we'll have x, but then be careful here. Notice that we did multiply both sides of the inequality by a negative number, and when you do that, whether you multiply or divide by a negative number, you have to remember that for an inequality, you need to flip the inequality sign. Okay, this is not something you had to worry about for solving equations, but for inequalities, whenever you multiply or divide both sides of the inequality by a negative number, you must flip that inequality sign. So instead of x being greater than or equal to this constant, x will now be less than or equal to that constant. Okay, and so we have 8 times negative 10 divided by 8, or really you could just cancel out those 8's, because 8 divided by 8 is 1. So you'd have 1 times negative 10, which is just negative 10. Okay, so x less than or equal to negative 10 is a solution set for this inequality, but now let's graph it. Let's put it on a number line. As usual, I will put 0 at the center, and then negative 10 would be somewhere to the left of 0 on the number line, and negative 10 is included in the solution set because x is less than or equal to negative 10. So I will draw a closed circle at negative 10 on the number line, and then point an arrow in the direction of values smaller than negative 10, right? X is less than or equal to negative 10, so values less than negative 10 will be to the left of negative 10 on the number line. Okay, but with that, we have now completed this example. Hey, real quick, before we take a look at the next example, if you find my videos here at JK Math to be helpful, then I'd like to invite you to join my membership site JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you'd get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. Okay, so if you're interested in becoming a member, feel free to check that out, as it's a great way to support me in the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. For our next example, we want to solve this inequality and graph the solution set on a number line. And we are given 2 times the quantity 5x minus 8 is less than or equal to 7 times the quantity x minus 3. All right, so in this inequality, we have a set of parentheses on both sides, so that's the first thing I want to focus on here. We want to eliminate or get rid of those parentheses. So we need to distribute 2 through this quantity and distribute 7 through this quantity. Once we've done that, it will be easier for us to solve for that variable of x. All right, so let's do that here. Starting on this side of the inequality, we want to multiply 2 by 5x and then multiply 2 by negative 8. That's how we will distribute that 2 through this quantity. And so 2 times 5x will be 10x. And so if we do that, you'll get 10x minus 16, right? 2 times 5x will give you 10x. You multiply 2 by the coefficient of that variable term, but then keep the same variable part. So 2 times 5x is 10x, and then 2 times negative 8 is negative 16. And so those two terms will be less than or equal to 7 distributed through this quantity. So you want to multiply 7 by x and 7 by negative 3. And so if you do that, you will get 7x minus 21, right? 7 times x is just 7x. 7 times that coefficient of 1 is just 7. But then you keep that same variable part of x. And then 7 times negative 3 is negative 21. Okay, so now the parentheses are all gone. We now have a simpler inequality to work with, and there are no like terms to combine on either side of the inequality. You always want to check for that because after you get rid of parentheses, sometimes you may have some constants or variable terms on either side of the inequality that could be immediately combined. That's not the case here, so let's just move on. We do want to solve for x in this inequality, so we need to combine our variable terms that are on opposite sides of the inequality. So we have to choose one of these two terms to eliminate by adding the opposite of it to both sides of the inequality. I will choose 7x, which means we want to subtract 7x from both sides. That will get rid of this positive 7x because 7x minus 7x will be 0, just leaving you with negative 21 on this side of the inequality. But then 10x minus 7x will be 3x because you want to combine the coefficients, and 10 minus 7 is 3. So we get 3x minus 16 is less than or equal to negative 21. Okay, and so now we just have one variable term, so we're getting closer to being able to solve for that variable. But what we need to do is get that term by itself on this side of the inequality. So we want to get rid of this constant term of negative 16, which we can do by adding the opposite of it to both sides. So we will add 16 to both sides of the inequality. Negative 16 plus 16 is 0, so those cancel out, just leaving us with 3x is less than or equal to negative 21 plus 16, which is negative 5. All right, and so then continuing our work over here, our next step will be our last one. We need to isolate x, which can be done by eliminating this coefficient of 3. And so what we want to do is divide both sides of the inequality by 3, and that will get rid of that coefficient. 3 divided by 3 is 1. 1 times x is x. So we get x is less than or equal to negative 5/3. Right? Negative 5 divided by 3 doesn't really simplify nicely, so I'm going to keep it as a fraction like that. And this would be the solution set. Notice that we do not need to flip the inequality sign this time around because we divided both sides by a positive number. Okay, even though we divided negative 5 by 3, we still divided by a positive number, not a negative one, so the inequality sign stays the same. Okay, but that would be the solution set for this inequality, but we still want to graph it. So I will draw a number line here. If this is x equals 0, then negative 5/3 will be somewhere to the left of 0 on the number line. And so I'll just say it's right about here. That's negative 5/3. If you do want to compare it to some integers or whole numbers, negative 5/3, if you put that into a calculator, is equal to negative 1.66667 and some more decimals. Really, it's 1.66666 forever. But as you can see, that fraction is somewhere between negative 1 and negative 2. So if you say that negative 1 is right here, and this is negative 2, negative 5/3 is a little bit closer to negative 2, since it's a negative 1.6, but regardless, that is about where it would be on the number line, and it is included in the solution set because we have x less than or equal to negative 5/3. So I will draw a closed circle at that value and then draw an arrow in the direction of values less than that number. Okay, x is less than or equal to negative 5/3, so we point our arrow in the negative direction. And there you have it. That is the graph of this solution set, which is the solution set of this inequality. All right, so here's our last example. We want to solve this inequality and graph the solution set on a number line. Okay, so the same instructions, but a different inequality, specifically the most complicated inequality that we have looked at so far, but it's nothing that we can't handle. The inequality is 2/3 times the quantity 9t minus 15 and then plus 4 is greater than 6 plus 3/4 times the quantity 4 minus 12t. And so the variable that we want to solve for here is t, and notice that this inequality has parentheses. So right away, even though this looks very complicated and it may seem intimidating to solve at first, if you see parentheses, work on eliminating those right away. That is the immediate first step for this inequality. So let's do that. We want to distribute 2/3 through this quantity and distribute 3/4 through this quantity. So let's start over here. We'll have 2/3 times 9t and 2/3 times negative 15. And so if you multiply 2/3 by 9t, you want to multiply 2/3 by that coefficient of 9, and then just keep that t on the end. So multiplying 9 into the numerator of the fraction, you'll have 9 times 2, which is 18. So we get 18/3 times t, and then we'll have 2/3 times negative 15. So multiply negative 15 into that numerator. Negative 15 times 2 is negative 30. So we have minus 30 divided by 3, or negative 30/3. And then don't forget about this plus 4 on the end there. So we have plus 4, and then that will be greater than 6 plus 3/4 distributed through this quantity. So we want to multiply 3/4 by 4, and then multiply it by negative 12t. And so starting with 3/4 times 4, you want to multiply 4 into the numerator. 4 times 3 is 12. So we get 12 divided by 4. And then 3/4 times negative 12t, you want to multiply 3/4 by that coefficient of negative 12. So multiplying negative 12 into the numerator of the fraction, negative 12 times 3 is negative 36. So we get minus 36 divided by 4, or negative 36/4 multiplied by t. All right, so now we got rid of the parentheses. Now let's work on simplifying anything we can before we try to do anything else to the inequality. And what I'm referring to are these different fractions that we have. They can be simplified further because 18 can be divided by 3. 18 divided by 3 is 6. So we have 6t, and then 30 divided by 3 is 10. So this is minus 10 plus 4, and that will be greater than 6 plus 12 divided by 4, which is 3. So we have 6 plus 3 minus 36 divided by 4, which is 9. So we have 9t, or really minus 9t. Okay, and then we do have some like terms that can be combined. We have 6 and 3, those are two constants, so you can combine them. 6 plus 3 is 9. And then over here, negative 10 plus 4, those are two constants that you can add, and negative 10 plus 4 is negative 6. So altogether, we have 6t minus 6 is greater than 9 minus 9t. And now we have an inequality that looks fairly similar to other inequalities that we solved earlier in this video. Okay, we still want to solve for t, so our next step here should probably be to eliminate one of those variable terms from one side of the inequality. I will choose to get rid of negative 9t, so let's add the opposite of that to both sides of the inequality, which means we want to add positive 9t to both sides. And so negative 9t plus 9t will become 0. And then 6t plus 9t, they are like terms, so add the coefficients. And 6 plus 9 is 15. So we get 15t minus 6 is greater than 9. Okay, and so we're getting closer to solving for t. We just have one variable term now, which is good, but we still want to get rid of this constant so that the variable term is by itself. So let's add the opposite of negative 6 to both sides of the inequality, which means we want to add 6 to both sides. And so continuing my work over here, negative 6 and positive 6 will cancel each other out, so we'll just be left with 15t is greater than 9 plus 6, which is 15. Okay, and so then our last step to solve for t is to get rid of that coefficient. So we want to divide both sides of the inequality by 15. So let's do that here. We'll divide both sides by 15. And in both cases, you have 15 divided by 15, which is just equal to 1. So you have 1 times t, which is just t on this side. And then over here, 15 divided by 15 again is just 1. So you get t is greater than 1. That is the solution set to this inequality. Okay, we did not have to flip that inequality sign because we did divide both sides by a positive number. You would only have to flip it if that number we divided by was negative, which it was not. Okay, so this is a solution set, but let's graph it yet. Let's put it on a number line. I'll let this be t equals 0. And then we are comparing t to positive 1. So I'll label positive 1 right here. And then the values of t included in the solution set are those that are greater than 1. So 1 is not included, which means we want to draw an open circle at 1 on the number line, and then draw an arrow in the direction of values bigger than 1, which are values to the right. And that will represent t greater than 1. Okay, and so with that, that is it for this example. We have now solved this very complicated inequality and graphed its solution set, but hopefully you can see that it really wasn't too bad. For these really complicated inequalities, you want to try not to get overwhelmed and just focus on one step at a time. If you see parentheses, get rid of those parentheses. Use the distributive property. After that, try to simplify any expressions that you can. If you have fractions, try to see if they will reduce. And then after that, try to combine any like terms, and then go about the solving process as usual. Try to get just one variable term, then isolate that variable term and get rid of its coefficient. Okay, but with that, this was the last example for this video, but if you do want to get some more practice, I have another example available on my membership site, so if that's something that interests you, feel free to look into becoming a member. You can find all the details on my website at jkmathematics.com/plus. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.